Hello and welcome back. This video is about my foray into the depths of training a LoRA for the FLUX.1 dev version, and what a sojourn it was. I go through my process using mostly SimpleTuner, but I touch upon AI-Toolkit very briefly. I experiment with many different configurations, such as the old vanilla base with no CFG distillation, flux guidance value equals 1, flux mask attention, and flux LoRA target equals all and all plus feed-forward connections. In addition, I increase the dimensions of LoRA rank and alpha to show the variations of the model outputs between them. Basically, higher dimensions are better. Finally, I dabble with LoKr, or low rank chronometer product, as an alternative to LoRA. All the experiments I performed use cloud compute through an H100 GPU. Keep this in mind if you want to replicate my configuration. You might not like to hear it, but as they say, the rich get richer. As always, everything is on my GitHub. Let's get started. The current tool that I'm using, which supports Flux fine-tuning, is Bagheera's SimpleTuner. If you go to documentation, then quick start, then Flux markdown file, there is a very well-written and detailed guide that will get you through everything that you need to know. If not, you can watch my previous video regarding SD32B medium training. In the second half of that video, I go through a very in-depth, thorough process on how I set everything up, how I generate the grids, etc. As of this recording, Hugging Face's diffusers also has it integrated in on this version 0.30.0. New pipelines, Flux. A third party has also implemented their own LoRA training and keys here. XLabs AI, XFlux, and they train LoRA and a control net apparently. You can use this as well if you want to. There's also this tool named AI-Toolkit by Ostrus. If you check his Twitter account, it seems like several people have used his repository and received adequate results, so I'm inclined to believe that this tool works well. Lastly, I don't know if one trainer has integrated the Flux training repository, but none of the above concerns us for the time being. As I mentioned before, I have already set up the SimpleTuner training environment, and if you watched the previous video, there's only a few minute differences that you need to make to your configuration file. First of all, I'm using LoRA instead of full fine-tune because that on FLUX.1 dev requires you to use deep speed 3, which causes some errors right now and it might consume too much VRAM. I just want to see how far LoRA can take us. So there we go. Second of all, change export flux equal false to true. Makes sense. And lastly, down here, make sure to export the correct model name. So instead of using the default STXL or SD32B medium, use Black Forest Labs FLUX.1 dev. That's it. That's all you have to change if you've been following the config from the previous video. At the time of this recording, I was using the main branch as specified in the Flux markdown file. However, Bagheera and his team have mentioned that they're installing on the release branch as well. So if you want to use either branch, just choose it from here. Up to you. Alright, enough background information. Let's just jump into some qualitative grids and I'll provide context along the way. Let's start off with this set of grids, which is of a LoRA trained on the exact same dataset as my SD32B medium model with a rank and alpha of 128. If we just jump down to the end here, remember that I set it up like so. I did train some LoRAs with a LoRA rank and alpha of 32, but they felt really horrible and undertrained. On the other hand, this LoRA rank 128 model was trained using BF16 precision, a dataset of 476 images, 3 image repeats of 1K resolution square cropped images, and a batch size of 1. It had a max steps of 42,840. The learning rate was 1.5 times 10 to the negative 4, which was a little high from my observations, but acceptable. Furthermore, at the time of the experiments, it seemed like if you used a batch size other than 1, the trainer would error out, and this is the GitHub issue that you would receive. If you ended up switching to a batch size of 16, it would train without an issue, but then you will be waiting forever. Also, you'll consume around 78 gigabytes of VRAM if you choose to go with a batch size of 16, so it's highly not recommended from my side. On that note, if you use a batch size of 1 on a LoRA with a rank and alpha of 128, you'll consume just around 38 gigabytes of VRAM. The reason why I'm using such a high learning rate is because I wanted to see if FLUX.1 dev had the same issue of overfitting to the text prompts of the dataset. In the case of SD32B medium full fine tune, it did, and the LoRA overfit to an extent as well. Also, you may ask, how did I know that I was using a high learning rate? Well, I got these expected exploded gradients when using a learning rate of 4 times 10 to the negative 4. So I just incrementally toned it down to between 0.5 times 10 to the negative 4 and 1.5 times 10 to the negative 4. In addition, I was able to get validation images to work this time using SimpleTuner, so I could observe in real time whether or not the training was progressing adequately. I generated them both for every third of an epoch for sanity's sake, so that defaults down to 476 steps. If we do a quick flip through of the validation images using our prompt, this is what we have. You can see that it's changing and doing its thing. I'm not sure what it's trying to do here, but this last image is genuinely horrifying. Let's also take a look at the unconditional images as well. Seems like not too much of a change. Okay, it's doing something. And there we have it. Seems fine for now. Let's go ahead and check out the performance of this LoRA on other prompts. Before anything is done, we need to check the validity of the LoRA. Namely, does the LoRA actually do anything? There are a lot of false FLUX LoRAs that don't actually have an effect released by people not doing their due diligence, so be very careful. This is an often very overlooked but very important step. So I've set it up here in ComfyUI. I've concatenated my trigger word and the prompt into the clip that is using the correct LoRA, and then I have a separate one just using the prompt itself hooked into another sampler. So we should be getting two very different things, one realistic, one stylized. Let's go. It's done. This is the LoRA, and this is from the base model right away. Great. It seems like the LoRA is having a definite stylistic effect here. This is the first grid generated from the LoRA with rank and alpha of 128 using this workflow. Let me run that. See, not making up anything. It's running. It's of a simple woman wearing a blouse like so. And this is the prompt, my trigger word, and then all this stuff here. If we scroll through the grid, it's not so easy to see the incremental changes. So I've stitched together the outputs in a video. Let's play through it. Here we go. Interesting stuff going on here. As an aside, something interesting that I observed in the workflow is that if you don't connect the LoRA down here to basic scheduler, let me go ahead and just remove it and connect the original model to here. It actually doesn't change anything. See? Forward, backwards. Absolutely no changes at all. Why is it like that? No idea. I also wanted to display some test output images from other seeds. Let's open them up and run through them. From what I can glean so far, I feel that the art style is definitely being learned, but the anatomy is being destroyed very hard. Just see more. Yeah. 2 arms on the left. And that's it. I had to generate several times and cherry pick a suitable image. So this one. You may ask, why don't you just turn down the strength of the LoRA right here? Definitely, we'll get to that eventually, but I'm just doing a global search right now for an ideal learning rate, number of repeats, and LoRA rank and alpha dimensions. Then you may also ask, why don't you lower your alpha dimension? In case you don't know what alpha stands for, we can consult the literature. More or less in the original LoRA paper, alpha divided by rank form a scaling factor that controls the magnitude of the updates through the learning rate. The higher this scaling factor is, the faster the adaptation. In addition, there is a very good paper here written by the LoKr's creator and friends. So if we jump into the paper and scroll down to section 3.2, controlling the merge ratio will result in a change of square root of gamma or just gamma depending on the used optimizer. Then it says see appendix B1, so why not? If we go down here to section B1 and read through this proof here, it says that if you're using an atom optimizer or atom-like, which we are in SimpleTuner, then you are scaling the learning rate by a square root of the merge ratio. As such, I think it's perfectly fine to use an alpha equal to the LoRA dimensions as the square root of 1 is just 1. I fear that if you go with an alpha dimension that is half of the LoRA rank dimension while using an add-in optimizer, you'll get too slow of an update as it will be scaled by square root of 0.5, radical 2 divided by 2, or just numerical 0.707. In my opinion, if we revisit the examples grids/video, I would say that the LoRA is still very undertrained. Let's try a different prompt now for the same rank alpha 128 LoRA and using the same checkpoint as well, 22848. Just eyeballing, I felt this one was pretty good. If you compare this image to the image output by future trained LoRAs, shown here, you can see that the expected behavior of a higher LoRA rank in alpha and batch size equals in a better quality output. As I mentioned before, rank in alpha of 128 as well as the low learning rate and batch size is just to get a baseline of where we should start from. Let's show the playthrough as well. Here we go. Even from far away, you can just see that this is not it. Let's try a castle now on the same LoRA as before. I removed the trigger word just to see the effect, and we get an image like this. Very interesting, because I don't have any of Craig Mullen's artwork in any of my training datasets. So, what's going on, Black Forest Labs? Let's do another test just for fun. You see that the Flux LoRA is not connected to this basic scheduler and instead connected to the original model, like one of the examples I showed before. Let's just connect it down here and see what the effect is. There we go. Nothing changes. Why is it like this? Does this only affect the basic guider and not the scheduler? Is there an issue with scheduling? What is going on? Let's check out the video while we're at it. Interesting. In the case of the castle, it was a little bit more difficult to see the changes because there were no changing anatomies. Now this time, let's go ahead and try out a creature, more specifically a dragon. Run it. This time, no trigger word as well, fiery red spores, and we get this very interesting image. I think it's pretty cool. If you guys are familiar with the book series Dragon Riders of Pern, this is what I feel like it would look like if it ever came to be illustrated. So we have these dragons fighting the thread, which is basically an existential plague or something like that. I see the style doing well. Anatomy more or less might be destroyed. I can't tell, but I like the feel. Let's do one more example in the form of an anthropomorphic robot. And run, here we go. I didn't have that many mechs in the dataset as well, probably less than 5 out of 476 images, but the style is doing pretty well. I like what's happening here. However, we still can't really gauge if the anatomy is being destroyed, but the style is certainly here, albeit kind of chaotic, kind of messy. Video once again. I actually like what was going on earlier instead of this open design. Now we'll do some humans again. Run. This one has the trigger word. I find that if you don't do the trigger word for humans, then it loses effectiveness of the style. Up until now, I haven't really been talking about the prompt adherence. This is not the time or place for it. I just want to see if the visual quality is being baked in. And this is what it looks like. Of course, it's not 100%, and this pose is kind of simple, so the anatomy does seem okay. But let's see what happens in the video. Here we go. And there it is. Once again, you may all have the honor of seeing the failed cases, which are plentiful. This is pretty good, but the style is not completely there. Oh, goodness. Yeah. A little bit tragic on some of them. The hand, look at that. What is going on here? Shouldn't the inside of the jacket be white? Not bad. 3 arms, hand, I guess. Oh, what is that? I think this is okay. She kind of looks like Serena Joy from The Handmaiden. For a model that prides itself on its anatomy, it's not looking so great on the fine tunes. As a caveat, of course, I haven't changed all the settings like max shift, min shift, LoRA strength, so we have to take those factors into account. However, holistically, we're not getting the best impression so far, in my opinion. For the last example, I'm going to run it on this prompt, which is an armored young woman. Didn't mention anything about a knight. So let's see that. And here we go. We have this image. Once again, let's check out the time-lapse, looping through all the incremental checkpoints. Let's play. I actually felt like the results near the end were better. Now that we have our 128 rank in Alpha LoRA, we can do comparisons with other higher rank LoRAs. So let's start here with these 3 videos side by side of our very first test of the woman wearing a white blouse. The first one on the left is the 128 rank in Alpha one that we've already seen. The center one is a 256 rank in Alpha trained with the same 3 repeats and a max steps of 42,840 and a reduced learning rate of 0.5 times 10 to the negative 4, as opposed to the 1.5 times 10 to the negative 4 of the 128 rank in Alpha LoRA. Then on the very right, we have a third LoRA, which is 512 rank in Alpha with the same 3 repeats and max steps of 71,400, trained at a slightly higher learning rate of 0.6 times 10 to the negative 4. Unfortunately, I wasn't able to save the earlier epochs or checkpoints of this rank 512 LoRA, so it starts from the checkpoint on 15,708 steps, which is just slightly greater than a fifth of the max steps. My apologies, I miscalculated the epochs when setting up my config files. When I view the iterations per checkpoint between these 3 different LoRAs, I find that there is less overall fluctuation in the outputs of the LoRAs with a higher rank. In addition, on the higher rank LoRAs, it seems like a lot more detail is captured. I think the increased train step size might play a large role here as well. In the case of the 512 rank Alpha LoRA output, there are semblances of a right hand resting on the right hip. It's still a bit too early to say, so let's look at a few more comparisons. This time, we'll be comparing the LoRAs for this example, which is of a male assassin. This is the prompt that I was using. In this showcase, we can learn a little bit more. Remember that the 128 and 256 rank Alpha LoRAs have the same max train step count, and the 128 rank Alpha LoRA has an even higher learning rate. Yet, it learns less and seems extremely muddy and splotchy compared to its 256 rank Alpha counterpart. Let's play the video again just to observe. In addition, I can make out that the higher rank LoRAs seem to converge on an output I like near the end, but not the exact last frame. So it seems like the checkpoint we're looking for is around the end of the max steps, but it's also not overtrained either, since we're getting updates to the final few images in the case of the 512 rank Alpha LoRA. Now we have the Castle sample. This one is a bit too difficult to discern differences between outputs, but it's displayed here as an example as to not overlook the effect of the style training on the environment pieces. The only definite takeaway I see here is that the 128 rank Alpha output suffers from the same splotchy, low texture resolution issue. So it makes me think that if you're trying to train in a difficult, high-resolution, painterly style separate from anime or photography, you have no choice but to use a higher LoRA rank in Alpha. Next up is this dragon. You might be wondering what exactly is the point of my going through all these examples. Well, I didn't have any, if at all, creatures in my dataset, so I wanted to show how well the style training would generalize to the final model. In the case of this space dragon, I felt like the higher rank Alpha LoRAs still output more defined images. It's arguable which one is better between 256 and 512 rank Alpha LoRAs, but I do want to point out that near the end of the 512 rank Alpha LoRA, the rear limbs of the creature fleshed out properly at the cost of the head morphing into some other shape. This is consistent with the 512 rank Alpha LoRAs so far, in which they changed composition drastically in the last 3 or 4 checkpoints. In the case of the 128 rank Alpha LoRA, the limbs are fused into a tail. Make of that what you will. Lastly, I want to point out that these higher rank LoRA outputs have a wider dynamic range. The 128 rank Alpha LoRA has too much atmosphere, but I'm not so sure how specific this case is. Now we have the robot. If you look at the final images, you might actually be convinced that the 128 rank alpha LoRA is actually the best looking or most detailed or defined. However, let's look at the later parts of the time lapse, especially for 512 rank alpha LoRA. On its final output, it's extremely painterly, which is highly representative of the dataset. It seems like it's going through a transitionary period, so if we added more to max step, then we should see more of the style baked in and settle on a new composition. If we just pull back one checkpoint once again, we have a more fair comparison. Here, I would say that it's really just personal preference. I can't really say that I would prefer one over the others here. Now we have an upper half body shot of the blonde woman wearing a dark bodysuit with a white jacket. I don't know about you, but this one seems pretty hard to decide upon. I honestly think any of them would work out fine. If we take the 256 and 512 rank alpha LoRA final output side by side, can you really say which one is better? I can't really tell with this small sample size. Lastly is the female knight. Just like in the case of the robot, it seems like the lower 128 rank alpha LoRA might be the best looking. However, I want to point out something interesting. This is the 128 rank alpha LoRA a little near the end. This is the 512 rank alpha LoRA halfway through the training process. Despite the 128 rank alpha LoRA having a higher learning rate, it learns features more slowly when compared to that of the higher rank LoRAs. This makes sense as there are just more dimensions to store information. This kind of proves to me that the 128 rank alpha LoRA just learns way too slowly. The later checkpoints of the 256 and 512 rank alpha LoRAs are already changing configurations, not just in this example, but a few others, and thus more of the dataset style is being trained in. If it was overtrained, it would just show new improvements and not change the entire composition. It's time for Act 2 of the Flux LoRA training. Up until now, I've been using an older commit of SimpleTuner. Since then, a number of parameters have changed. The most important one is flux guidance value, which was not added in or set on the older commit. So if we type that in, flux guidance value, we have inference tips, a lot of stuff here, classifier free guidance, and all that detail down there. It's all a bit technical, so it's just faster if I show you the models trained with this value and without it, then compare the inference differences in ComfyUI. Then we can come back here and understand more of what this is saying. Here we are in ComfyUI. The LoRA loaded in the upper half of this workflow is a much later training I did on an older branch of SimpleTuner, as evidenced by this LoRA 9. But it didn't have flux guidance value or flux masked attention integrated in. It's a 768 rank alpha LoRA trained with 5 dataset repeats with no flux guidance value parameter at 71,400 steps and a batch size of 1. If we zoom back out, there's a lower half here as well, which is one of the final LoRAs that I ended up training after a grueling ordeal of experiments, as evidenced by LoRA 22. You can see how many LoRAs I trained in between to get this perfect. There is one more model after this that I chose as my final LoRA model, but I'll get to that much later in this video. This LoRA, LoRA 22, is also a 768 rank alpha LoRA, but I manually duplicated the images and captions while shuffling the captions as well. This means that I did not use the dataset repeats inherent in multi-backend JSON, and I also didn't use any caption dropout. This LoRA training had the flux guidance value parameter set to 1 as well as a new parameter called flux mask attention enabled. Contrary to the above LoRA up here, this LoRA was trained at 23,800 steps at batch size of 6. Let's go ahead and run. I've muted the lower part here and the upper part up here. This image here is one we should be familiar with. It's using a flux guidance of 3.5 with the older LoRA with no flux guidance value set at all. Down here, we have flux guidance value training set to 1, and we're using a guidance of 3.5, and we're getting something vastly different. If we do the image compare node, we can see how different it really is. So what does flux guidance set to 1 during training actually do? Well, this is 3.5 here, Now let's come down here, same final LoRA, and now let's change the flux guidance to 1 and we'll enable this node, let it run. Let's see the results. This is the output, and I've dragged down this 3.5 on the older one down here so we can compare. They're almost the same. This is the older LoRA with no flux guidance, and this is the newer LoRA with flux guidance set to 1 during training, and now set to 1 during inference as well. So maybe the result is not as good looking, but maybe it is better looking depending on what you want. However, that is not what we're here to discern. Now let's go to the upper workflow and run this node. However, this is going to be our experimental run. If we run it with 3.5, we'll just have what we have here. Let's go up. So maybe a 10. Unmute and run that. Here we go. It's very muddy. And then how about we connect an image compare to compare between this 3.5 and 10 with the power of editing. This is flux guidance at 3.5, flux guidance at 10, 3.5, 10. So going up makes it more painterly, perhaps. What happens if we decrease it? How about 0.5? What happens now? At 0.5, it also becomes muddy, but it still keeps the same composition. Nothing is changing. So what does flux guidance scale really do when you train without it? Well, I'm not so sure myself. However, why don't we come back here and instead of using 3.5, we go to 10. Same trial. What will happen? Now we get this. It seems a little bit more realistic, but still keeping some elements of the painterly style. I can't say for sure. Why don't we go down to 0.5 as well? I just want to point out that the composition is changing. And here at 0.5, the composition is changing as well. Whereas when you use the LoRA without any flux guidance during training, then you keep getting a fixed composition. Now that we understand a little bit more about the empirical results, let's go back and check out the SimpleTuner quick start guide to Flux once again. If we come down to classifier free guidance, it says a value of 1 or flux guidance scale equals to 1 will preserve the initial distillation done to the dev model, and it's supposed to reduce the creativity and output variability of the model as with the original flux dev model. However, in our experiments, this is not true. If we go back and look at this, the upper half of the workflow is the LoRA that was trained without flux guidance scale set to 1, and this one's composition is unable to be changed despite any value of flux guidance that we're using. See, at this value of 5.7, it's still not changing. So I think this might be the opposite in this case. Then down here it mentions a higher value around 3.5, 4.5 will reintroduce the CFG objective into the model. I'm not sure if this is true because if you train with the flux guidance of 1.0 and then run it here while changing the flux guidance, you can get different compositions. This is 0.5, and if I do 5.5, I'll get something completely different. There we go. Perhaps I'm misunderstanding something here in the documentation, but this is what the results show me. It's time to show off the final two LoRAs trained with SimpleTuner that I finally liked. They were both trained with these exact same settings, but the final one that I chose was trained with All+ffs for the Flux LoRA target parameter. So if we click on Options MD and search for FFS here, if you read what All+ffs does, all layers will be trained including feed forward. In addition, if we go back and read another part here, training just the MMDIT blocks keeps the model very stable but does not change it a lot. Using All+ffs will LoRA absolutely everything, and it gives you an extra message of warning here. Limited compatibility with other platforms and might not be the best choice. On that note, let's go to this GitHub issue over here. It was opened by me 2 weeks ago. Oh, time flies. And the problem was that the LoRAs work, but ComfyUI does not support All+ffs mode properly. Later on in ComfyUI's GitHub issues, it was solved with a later commit by Bgira. As such, it was resolved a while back, so you won't run into it anymore. Once again, the best way to demonstrate the differences between the models are to do the A/B testing like before. Given the examples from before in ComfyUI, you already saw what happened when a flux guidance of 3.5 or higher was used. It made the images look worse and maybe a little bit more realistic, but I don't know. So I ran this set of experiments using the same fixed seed, but with the flux guidance set to 1. First up, we have this male armor sample. Right off the bat, the final image for All+ffs is already pretty clean even at a flux guidance of 1.0. This means that it is at its most stylized unless you dip lower than 1. In addition, starting from the last fifth of the checkpoints, the composition barely changes, so I feel like this All+ffs model has already reached training parity. On the contrary, the model trained with flux LoRA target equals all is still jumping around even at the end of its max steps. Furthermore, even if we select the output of an earlier LoRA of the all model such as this one, it feels just a shade splotchier when compared to the output of the All+ffs model. This first round definitively goes to All+ffs for sure. Next up is the castle. If we just look at the final images, you can see that the final one for All+ffs has more structure. The ridges of the sculptural buildings are more defined as opposed to the output of the all model. However, it's a bit difficult to tell. Let's look at the last fifth of the checkpoints again. I think it's close, but it feels like the all model rubber bands from slightly defined to blurry, while All+ffs goes from slightly blurry to more defined at the end. All+ffs edges it out by just a little bit here. Now we have the space dragon. The final image on the All+ffs side has a more defined foreground and wing structure when compared to the final image on the all side. These are the last fifth of the checkpoints once again. Both stay on the same composition, so the models are thoroughly trained. Once again, I can't shake the feeling that the All+ffs model just has more definition and delineation to it. Time for the robot once more. I really prefer the final image for All+ffs here. The one on the left feels more detailed, but it gives off a cluttered feeling. I rarely ever generate a detailed finished image and much prefer to start with a rough base image with base colors and some line work, which I then flesh out. If we're speaking detail-wise, I think the model trained with all might have an edge here. At the risk of sounding like a broken record, it could go either way based on your personal taste. Lastly, we have the female knight. Final images seem comparable, but let's just check the time-lapse just to be sure. Once again, in the last fifth of the training checkpoints, the composition remains pretty stable for both models, so it's hard to tell which model is superior. However, please recall that I'm working with a set flux guidance of 1 for all generated images. This means that the LoRA is at its truest form, so most stylized. What happens if we vary the flux guidance and plot it against each checkpoint? You've guessed it, it's time for the XY plots once again. Now that you have a general feel of how much All+ffs changes the outputs, it's time to plot checkpoints versus flux guidance in a grid. In these examples, the x-axis is the checkpoint number, so from left to right it increases, and then from top to bottom I increase the guidance in 0.25 increments starting with 1 all the way up to 3.5. So 1, 1.25, 1.5, so on and so forth. Like so. Forgive me, I did not do the decimal rounding correctly, so this is just rounded down or up, depending on what it feels like. Let's start in respective order with the male armor. Just to refresh your memory, this is the prompt. Remember the gripes that I had with LoRA 22, which is the model trained with the flux LoRA target equals all. The outputs were more splotchy / undefined and changing compositions a lot, even at the end of training. So here we go, move checkpoints around checkpoint 22,000 and morphs to this standing posture, then another person stays consistent and then goes back like that. For the time being, let's look past these shortcomings and see what happens when we increase the flux guidance parameter. As I mentioned before, the top row is 1.0, then it goes to 1.25, 1.5, 1.75, 2.0, and around 2.0, it starts getting semi-realistic or realistic. Let's just look again. Up top, it was more painterly, it had that illustrative feel, and then when it goes down to 2 around here, the face is becoming very realistic. Let's go all the way down to 3. At 3.0, it's nearly realistic, and keep going. Then at 3.5, it could pass as a deep fake or realistic photo bash. A tertiary detail I want to point out here is that the anatomy seems to improve when you increase the flux guidance. I think the reason here is that when you train with a really heavy style, you run the risk of destroying the anatomy. So here is at 1.0, the style is at its strongest and it's destroying the hand somehow. But if we let off on the style a little bit by turning up the flux guidance, yeah, the hands seem to come back, albeit not perfect. Maybe it's not up to your standard, but it looks a lot more cohesive than before. Let's also head over to LoRA 23 or the All+ffs model just to check out what those grids look like. Move to the end here. Oh yeah, this is it. Composition not changing. The images look really sick. It added this teal color in here, which balances very nicely as an accent and then brings it back in. Let's go down, increasing the flux guidance, becomes more defined. It's losing some of the style, but we're gaining back some of the anatomy or realism. And if we push really hard up to 3.5, we start getting photograph level of quality for the face at least. This could do very well for a photo bash on a concept design if you need realism, or if you're designing for film, this would be excellent, especially down here at 3.5. This looks very good if you want that kind of style. However, for me, I would stick around 2.0. I like where this is maybe a little bit more painterly. 1.75 here, 1.5, maybe even 1.25. Yeah, maybe. Now, let's look at the grid for the Space Dragon. Before we even do anything, go to the right end of the grid for the latest checkpoints. Then I'll just alternate between both grids by switching Photoshop tabs. So the one that you see right now is the All model, so LoRA 22. Toggle, this is LoRA 23, All+ffs. 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 You can see the checkpoints are matching up. 223026. Same here. Notice any differences? All+ffs feels so much more vivid. My eyes are drawn to this grid more. It just pops. Perhaps it's just a good seed, but who really knows? Let's return to the All model right here, so LoRA 22, and increase the flux guidance again. When we increase by 0.25, getting something like that. It's still within the realm of acceptability for me. And then around here, this is when it starts doing something really weird. And before I continue, I want to stay here on the earlier flux guidance values. So this one is at 2. Look at the clouds. They still seem kind of painterly, and if we increase the flux guidance, the clouds become more realistic. It's almost DreamWorks-like. Just like the example in the male armor, when we increase flux guidance, we're losing the style of our LoRA. Here we have something quite bad looking in my opinion, but you've seen it before already in the ComfyUI part. Yeah, so if I were using this LoRA, I would definitely not want to go up to 3.5. And I don't want these DreamWorks clouds or whatever these are. They look quite poor. Let's also go over to LoRA 23 or the All+ffs model and check the outputs there. Increase the flux guidance. This looks really, really cool. It looks like a Moltres, sort of. And we're getting painterly texture for the foreground and background. This is maybe near the middle, looks still illustrative. It starts to become more realistic, but not really. It's hard to describe. It feels like it's more defined. The structure is there. Yeah, here it's not so smoky. This looks like a more Western style dragon now. And then at 3.5, I don't know. I like it more than whatever All was giving us at the end. This looks really not great. This I can deal with. Yeah, not so bad. The background and foreground is also still retaining its painterly or illustrative qualities. It's not becoming very realistic in this case. These clouds almost look like a matte painting. Now it's time for the robot. Start with the All model. Increase the flux guidance at the end. 1.25, 1.5, and around 1.75 it's becoming realistic. And then we get to Boston Dynamics level or Vitaly Bulgarov. Maybe they're both in the Flux pre-training set. Who knows? And then, yeah, becomes pretty standard down here. Let's also take a holistic look at the All grid. Some of these look okay. Nice, I guess. Somehow they become female. There's some interesting ideas in here. This looks nice. Maybe a good middle ground. If you want that painterly texture, you gotta let it run more. Yeah, I still think choosing from the end is very good and then modulating with the flux guidance value. However, as I mentioned before, I felt that All+ffs was better. Let's check if that's really true. Why don't we start with the holistic view here as well? This is looking really nice over here. We're getting a lot more variety, especially with this head design. Eventually smooths out into this part, gestational mechanical embryo. All right, let's look at the end and check out what flux guidance value does here. First off, we have two different compositions at the end. This head looking to the left, and then this one with the bent arm. Increase flux guidance. I really like this one right here. This one too. I believe it's at 1.75. 2 looks really good as well. As I mentioned before, 1.75 and 2 were my favorite ones. Up here, we're getting into the realm of realism. I still like what's going on here despite it being more realistic. Yeah, it's good and still very nice looking. Let's do the toggle that we did with the dragon. So all here, All+ffs, and then all here. The images on All+ffs, they just pop more. They draw my eye there more, or I'm more interested in what's going on here. In the all model, I just don't really care. It just doesn't have that lighting spark or contrast. Maybe it's still too muddy. I'd rather look at these two images than look at whatever these are, even though they're the same increment and final checkpoints. In the case of All+ffs, even the interesting qualities propagate down to the higher flux guidance value, around 3 and 2.75. Even at these higher values, I still like what I'm seeing. Maybe I can break this apart for use in a 3D package. Who knows? Female knight again. You guys all know the drill. This is trained with just all, and let's do a holistic scroll through. I actually like some of these already. This is good. I like the attitude on that. Keep going. Yeah, this is pretty good. If I zoom out, they look good from afar, but maybe far from good. Close up. No, actually this section looks very good and it's holding steady. Let's go to the end. Oh wow, I really like what this one's doing. This section is very nice. This as well. At the max steps right now, scroll down to increase the flux guidance. We should be getting more realistic and losing more of that painterly texture or the LoRA texture. Still okay, and now it's falling apart back into mediocrity or the mid-journey style or a more general format. Don't really like what's going down here. This is way too generic and it's losing almost all of the LoRA quality we worked so hard to train in. Even have a little damburu action going on here. Alright, it's time to bring out All+ffs. Here we are. Same thing, let's do a little holistic scroll through as well. This is really nice, actually. I really enjoy what's going on here. Can't say the same for the other parts. It's actually falling apart down there. We're at the end. Scroll down, increase the flux guidance. For this LoRA, I prefer around 1.75 or 2 for the flux guidance. Oh, this is 1.75, this is 2, as it's the midpoint between full-on style and degraded anatomy. However, if we keep going and look, this is alright, but then not so good, and then too generic at the end. This looks like a Fire Emblem character. Anyway, I would prefer images that look something more like this. This is quite nice, and if we decrease the flux guidance, yeah, we get something pretty okay. Not the best, but I like the feeling of these images. I don't really like what's going on here, and yeah, not so great there. Random witch sighting. It's possible that all might be outperforming All+ffs here, but I still prefer All+ffs just for the sake of the image impression. I'm okay if the image doesn't look that good close up, but looks good from afar, because that's how alla prima painting works, or thumbnailing, as you know in concept art, which is one of the areas that generative AI excels at. So yeah, I think we can wrap up this section for this LoRA. As we're winding down on this video, aka I'm getting tired and just want to get my experiments and findings out in the hopes that it will serve as a good springboard for future iterations by you viewers, I would like to go over a few miscellaneous items, hence this section. I actually trained a second Flux LoRA with a dataset of cinematic photos. This was a validation set created just to see if my training config for the fantasy art dataset generalized well enough. I call them cinematic photos, but it's hard to succinctly explain what they are. Most of the shots in the dataset were pretty moody, atmospheric, and underexposed. If you know who Greg Fraser is, he was the DOP for Dune, Dune 2, and the new Batman movie. I looked for real-world photos that resembled his style of image capturing. In addition, if you know the YouTuber Timu or Timu MP4, I also tried to source images in that kind of style as well. The images in this dataset were not limited to only 1K resolution, but had all types of aspect ratios over 460 images. Enough talking, so let's go ahead and run this. The top one in purple is going to be the cinematic photo. The one on the bottom is going to be the fantasy art or painterly texture LoRA, and the one in the middle is just going to be the good old vanilla Flux model output. So here we go. It is pretty drastic, I would say. This one is the cinematic photo LoRA. It's very underexposed, almost like a vignette, but not really. There's a mist filter. And then we go over to the default Flux, which is this. Depth of field, everything is well lit, no vignette, no mist filter. It's very subtle. I have a compare node so we can look at it like this. This one just feels a lot more something that you would see in a movie. Atmospheric, it has that very classic, really overdone teal and orange color scheme. And then we have the painterly one, which is more my speed, but I like to be chaotic, illustrative for concepts. So there it is. Why don't we do one more example? How about a waterfall? Here we go. It's running. The painterly one already looks very nice. Then we have this. It's not super cinematic. And then finally this one. Yeah, this is the cinematic one, and then this is what you get from the Flux one. Actually, the cinematic one is cinematic more so. You can see vignettes in the bottom left and right. This one is not so much, and it just feels flat. It doesn't feel that great. On this one, we have that atmospheric haze on it. So I would say it's subtle, but it's doing its job. And then this is the painterly fantasy art. I really like this one as well. So the purpose of this was to just show that, yes, using my settings on a realistic data set could train a style in. Jury's still out, but I do see a notable difference. It might be more difficult to discern if your dataset is realistic and you're training this kind of color grading concept into it. Here is just one more example I created to convince myself and hopefully you guys as well. It's a simple female knight posing for the camera, fashion shoot, and then my different trigger words. This is for the cinematic LoRA, and this is for the fantasy art style. Okay, and these are the results I end up getting. This is the cinematic photo. It looks quite nice. It almost reminds me of the 300 Zack Snyder kind of grades. Say what you want about the movies. The visual detail is always there. And then we have the basic Flux over here. Very drastic difference. Once again, it just has that faded color grade. The darks are brought up, whereas the darks in here are very dark. Great. And then we have the fantasy art dataset model. So this one, as always, beautiful in my opinion. Maybe the anatomy needs some work. Why don't we try one more example? I'm not sure what to do here. Here we go. A bridge during sunset. Beautiful ocean. Tell me this isn't cinematic. It's done. Let's go over to the RG3 compare node. Cinematic photo first. Then we have vanilla Flux output, cinematic photo, vanilla Flux. It kind of feels like even the cropping and HDR is baked into the cinematic photo LoRA. There's more leading lines in this image. It makes sense. Just has no art direction to it. Just my opinion. And then let's check out the fantasy art. As you would expect, has that painterly texture still. So I hope I was able to convince myself and you all as well. In this section, I'll touch upon low-rank chronicle product or LoKr as an alternative to LoRA. So LoKr is part of the Licorice module. It's the first time I've ever worked with this type of format, so I just followed the configuration files set up on the SimpleTuner documentation for Licorice on this page. Basically, this is going to be in a separate file that you load in alongside your default config. And then you add this and this to the config. You'll see when I share my final config. This is just a side quest experiment to see what LoKr is capable of and how it stacks up against the existing 768 rank alpha LoRA with all plus feed forward connections trained. Let's start off with the robot. Puppet mannequin, have my trigger work, and there we go. Let me bring up the image compare nodes just to make it easier to visualize results. So we got one there, and then let's do one between the stylized and the base. Okay. Down here is the output from vanilla Flux with no LoRAs attached. This is the one we all know and love. 768 rank alpha LoRA with all and feed forward connections trained. And then this is LoKr. I'm not sure what the ideal guidance value to use here is, so I put it at 1.3. If I go to 2, it becomes more realistic. Let's just run it and see how it changed. It follows the same behavior in which increasing the flux guidance makes it lose its style. So maybe I'll just leave it around 1.3 or 1.4. This is LoKr at flux guidance 1.4. And then this is the 768 rank alpha LoRA with all plus feed forward. It's very, very good, as you can see. And LoKr is kind of bad, needs work. At least it's better than the base Flux. Let's try some different prompts that I set up before. So this one, the male assassin, and make sure we have the correct seed. Run. All right, so let's start off. This is the basic Flux. Then we have the beautiful, immaculate 768 rank alpha LoRA output here. A little comparison, it's just so much better. And then up here we have LoKr. It's pretty tragic. Maybe if I up the flux guidance to 3, I can give it more definition back at the risk of losing its style. Yeah, so if I go up to 3, it's basically losing most of the style. Maybe 3 is too strict, 2.5, maybe 2. This is with 2, it's okay. We can bring back some of the painterly texture, but obviously LoKr is not very good. Now let's try, how about the dragon? There we go. Run. Once again, let's take a look at the tragedy of the base Flux model compared with the image from the 768 rank alpha LoRA. Just, it's so good. And then we have LoKr up here. Yeah, it's up to you. It's not unusable, but why would you use this when you could just use this? This is like AI-Toolkit level. This is production level. Finally, let's do an environment just so we're not being biased. And copy that. Once again, we can take a look at the images. This Flux-based model is nothing worth writing home about. This is the best image, as always. And then we have LoKr. This one isn't so bad, actually. If we compare, yeah, it's okay. Not as defined, still muddy. At least it's probably better than the older versions without flux guidance value at 1. Let's also change a seed to see what it looks like. 768 rank alpha LoRA, and then LoKr. Let's compare. Yeah. It's possible I don't have the correct LoKr settings. However, I kind of doubt it. I never received outputs from Licorice that outperformed base LoRA, but it's possible that I haven't figured out the ideal settings for Licorice. There it is, the short side quest into LoKr. I would be remiss if I did not mention AI-Toolkit. It's one of the other repositories that I mentioned in the introduction. I did test it, but not as extensively as SimpleTuner. This is the config that I used. It ranged from barely acceptable to really poor for 60 or so images. For 766 images, it does extremely badly. I quickly gave up on this as I let it train for 4 days on 40,000 steps, of which 30,000 steps were at batch size of 1, and the resumed training was 10,000 steps at a batch size of 6. Even at such a high step count, it still gave me really messed up results. Both trials used a learning rate of 1.5 times 10 to the negative 4. Also, if you want to have batch size that isn't 1 and doesn't error out, you'll have to disable this linear time steps equals true, so either comment it or set it to false. Anyway, bottom line is, if you prefer lower quality images, LoRAs that take forever to train with poor results, or just don't have time to spare in fine-tuning a model to the best of your ability, I recommend you to use AI-Toolkit. It just works, sometimes, but not really. If you prefer high-quality images, good documentation, and responsive developers and engineers, SimpleTuner is where it's at. As always, on this channel, we can't just talk the talk, but we have to walk the walk as well. Here we are in ComfyUI, where I've set up a comparison between the models trained with different repositories. Let's go ahead and run it. Same prompt for all of them. The truth will set us free. You've seen this one already. This is the SimpleTuner. And then we have this one, the 4-day LoRA training. Truly, we're home, and nation's prayers have finally been answered. Let's just hook them up into the compare node to see just what a drastic difference there is, or if there even is one at all. Run that. Here we go. SimpleTuner, AI-Toolkit, SimpleTuner, AI-Toolkit. I definitely think the quality could be improved if we just trained for a few more days or weeks. Just 2 more weeks to be sure. For reference, this LoRA was trained with only 1 repeat. Fantastic. If you don't have an irony deficiency, SimpleTuner trained this LoRA in about 20 hours with 5 repeats. And then we have the 60 image LoRA down here. Don't forget that all 3 of these were trained with a rank alpha of 768, so we're not playing any favorites. This one took about 8 or 9 hours to train. AI-Toolkit, as it lives and breathes. Why don't we vary the seed just to check the robustness? So this is a different seed, SimpleTuner, AI-Toolkit, and then the 60 image LoRA. Just incredible results. Fascinating. Why don't we try another prompt as well? Do we go with the dragon or the knight? Why don't we do both? Random seed. I have no idea what it's going to give us, but I have no doubt that we will get excellent results from the AI-Toolkit. It's done. So we got SimpleTuner over here. Then we have AI-Toolkit. Yes, I really love my dragons to be bisected. Great. And then we have the 60 image LoRA. Wonderful. Lastly, let's do the knight again. It's done. So let's take a look. 768 rank alpha LoRA. This looks pretty sick in my opinion. Damn, I want to use this now or do some kind of variation. And then we got AI-Toolkit. I mean, it's trying its best. Look at this majestic design, and then SimpleTuner at home, SimpleTuner at home, and then the 60 image dataset LoRA. This actually looks pretty cool as well. So I would say it's up to you. You can try what you want. For me, I prefer the SimpleTuner look and optimizations. If you really want to use AI-Toolkit, Bigera has actually integrated this into SimpleTuner in the FLUX LoRA target parameter here. Just change this to AI-Toolkit and you're set. In all seriousness, All+ffs might have some good ideas, but his or her repository is a sandbox for their own personal use. As of this moment, it doesn't seem ready for scaling and production, but maybe it will be in the future. There we have it, the FLUX.1 dev LoRA exploration. I'm sure there are going to be many more improvements, discoveries, and insights surrounding this family of models. However, the ecosystem for Flux is still very immature, and the results, in my opinion, don't warrant such a high compute and waiting cost. Not only does it cost a lot of money and time to train a single model, it also costs a lot of time to wait just for a single generation. On an RTX 4090 GPU, it takes around 30 to 60 seconds even when using a quantized model, which is unusable for the kind of rapid iteration design work that I need to do. There's just too much mental latency. For projects that have short turnaround periods, such as I need this in 2 hours or within 1 day, I would say stick to tried and true tools for now. On the other hand, if you just need a volume of images that you don't have to iterate on, this might be the state-of-the-art tool for many general users. Personally, I want to try out full fine-tuning as well as contribute to quantization efforts surrounding Flux models, but we'll see. Thanks for watching and see you next time. Bye!